All right, you guys, I think your sheet has the wrong objective on it, because that was like from before. So the objective is actually to use the law of cosines to solve triangles when the law of sines is not applicable. So in order to use law of sines, you have to know an angle and a side that are opposite from each other, right? You have to have at least one angle and one side known that are opposite of each other. So if you don't have that, see if you can use law of cosines. So for law of cosines, you can either have side, side, side known, where you know all three sides, then you can use law of cosines. Or you can have side, angle, side, where you know the angle in between the two sides that you know, then you can use law of cosines as well. All right. So here's an example of one where we can use law of cosines. And could we use law of sines, you guys? No. No. You would have to know one angle and one side opposite in order to use law of sines. So then you look for law of cosines. And we do have law of cosines here because we have a side that's known, an angle that's known, and a side that's known. So we have some SAS, all right? So the law of cosines formula is this, which you just kind of want to memorize, you want to know it. And it's really important to note that this angle is always the angle in between two sides. And the two sides that this angle is in between are these two sides in the formula A and B. So you'll see as we plug in here. So x, we're actually talking about this angle C right here. X is across from it, that's little c. So I'm going to do x squared equals. Now I have A and B. These are the surrounding sides. Order does not matter. So I'm going to do 7 squared plus 10 squared minus 2. And then I plug those in again. 7, 10. Cosine of the angle that's in between those two sides that I just filled in. So cosine of 36 degrees. You can plug this all into your calculator. One big long thing right here. So you guys go ahead and grab your calculator and make sure you plug it in correctly. Like that. All right. So I'm going to plug this in. 7 squared plus 10 squared minus 2 times 7, I'll use parentheses, I guess, times 10 cosine of 36. All right, press enter. We got 35.738. We'll round to 3 decimals. Yeah, I'm not done. You guys, I was getting there. Wait, that is not right. Okay, we're not done. So that's equal to that, right? And then, of course, this is an x squared right here. So I need to square root my answer. And again, always use second answer or your previous thing on your calculator. So I'm going to do the square root of that. Or I could have plugged in the square root of this whole thing at the beginning if you want to. And I get 5.978. Make sure it makes sense. A lot of times you'll know if it doesn't look quite right. That looks right to me based on what these other sides are. All right, so that's one example. This one's a little bit different. Find the measure of y. So this time I'm missing the angle. You always look to see, can I use law of sines? And can we use law of sines? No. You have to have one angle and one side right across from each other, so no law of sines. But I do have side, side, side. So if you have SAS or S, you can use law of cosines. All right? So here we go. Now, this is the special angle in between the two sides. So I need to start with this one on the opposite side. So it goes 8 squared. And then these are the surrounding sides is equal to 5 squared plus 7 squared minus 2 times 5 times 7 cosine of y. That's what I'm trying to find. Okay. So always plug in this side that is opposite the angle you're talking about on the opposite side. All right? And then these two sides should always be the two sides that surround the angle you're talking about. All right, now we should probably do a little, algebra. We need to isolate this trig function. So I've got 64, and then 5 squared is 25, and 7 squared is 49, and 2 times 5 times 7 is 70 cosine y. And we need to subtract 25, and we need to subtract 49. So I'm going to subtract 25, and I'm going to subtract 49. So 64 minus 25 minus 49 is negative 10. We still have not fully isolated the trig function because I have to divide by negative 70. All right, so on your calculator, you could go ahead and do negative 10 divided by negative 70 and get a lovely decimal answer for that. 0.143 equals cosine y. So in order to isolate this cosine, we need to do the inverse cosine of both sides, and that will give me the answer for my angle. So I'm going to go to my calculator, I'm going to do inverse cosine, and I'm going to press second answer so that I can just plug in that 0.14 number. And we get this lovely angle. So my answer is 81.787 degrees. And again, it's a degree sign because I solved for an angle. Make sure it makes sense. That looks acute. We got an acute angle, and that is law of cosines. All right. I hope I am. Okay. Last one. 2 cables are attached to a vertical tower. All right. From the same point on the ground, the angle in between the cables, so these are my 2 cables, the angle in between is 15 degrees. So I'm going to label that 15. The longer cable is 150 feet long and is attached to the top of the tower. So this is the longer cable that is attached to the top of the tower. The shorter cable is attached 50 feet below the longer cable. So here's the shorter cable, and it's attached 50 feet below where the longer cable is. So that's a 50 right there. Find the length of the shorter cable. So I'm going to label the shorter cable right here X. So can we use law of sines? We, in fact, can. We have this angle, and opposite this angle is this side. So let's use law of sines. So I also cannot immediately find this side, right? Because do I know this angle here? I do not. So I can't go straight to the answer. Got to do a little extra math. So I'm going to start with sine of 15 over the opposite side here of 50. And I'm going to find this angle first. And it is opposite this side of 150. So I'm going to do sine of, I'll just label this angle B, whatever you decide, over 150. And I'm going to cross multiply. So I have 150 sine of 15 equals 50 sine B. And I'm going to divide by 50. I'm going to put that whole thing in my calculator. 150 sine of 15 divided by 50. All right, and that is not the answer. Some people are doing this weird on their test. You're like, I don't know, multiplying by 100 and making it an angle. I think that's kind of weird. Don't do that. All right, you have 0.77 something equals sine B. How do I find the angle here, you guys? Yeah, we got to do inverse sine of that decimal. So I go inverse sine and just go second answer because then it's more exact. And I get 50.937. Okay. So now I can find the missing angle up top. So if B is this 50, Oh wait, does that seem weird? Yeah. So when you go and you're like, oh, I'm going to put a 50-degree angle right here, could this be a 50-degree angle? No. Nope. Just nope, right? It can't be. So because our calculator only gives us acute angles, and that is an obtuse angle, we need to subtract from 180. So I have 180 minus, and I get 129.063. Now, that is this angle here, 129.063. That is the obtuse angle. Now I can find this angle up top right here because of triangle sum. So 180 minus the 15 that we know minus the obtuse angle that we just found gives me the angle up top, which is 35.937. So we got lots of extra math on this one. Now we can finally solve. So I had to find both angles before I could find the missing side. So we would set up the last law of sines. It is best to start with what you know is right. So I'm going to start with sine 15 over 50. And I'm going to set it equal to sine of the angle we just found, 35.937. And I'm going to divide by x, the missing side. And you guys would cross multiply like you've done a whole bunch of times. And you get 113.380 feet, because we are talking about a length and not an angle. All right. One whiteboard problem.